Quiet mode. Quiet mode. Did I already do this? No. Quiet mode. Quiet mode. And quiet mode. Alright, look. I could solve this equation right here. I could solve it. But I gave you the graph. If I give you the graph like this, you should be able to just look at it and immediately know the solutions to that equation. Why?
Because you can see the line, you can see it turning.
Tell me the solutions.
Neither.
No, there's numerical answers.
Wait, can I still tell you the solution?
Jump, go, redeem.
It's 1, -9.
That's close. You have the right idea, but you're not quite looking at the right spot.
Here's my real life, huh?
Where are the solutions? DJ, go, try.
-2 and 4.
There you go. It's the x-intercepts. Show you where the solutions are, okay? The solutions themselves, in this context, are called the zeros of the function. All right? It's right where the x-intercepts are. So the solutions to this equation are the same as the places where it crosses the x-axis. So the two solutions at a glance, without solving it, I immediately know are -2 and 4. All right? Those are also called the zeros of the function. They are also called the roots of the function. These are all synonyms. Solutions, roots, zeros, same thing. All right? Now, like if we were going to do this old school, we would have factored it, right?
Do you want us to?
Yeah, we're going to do it. Because it said solve by graphing and factoring. So we just solved it by graphing. Now we're going to do it by factoring. X squared, right, Mr. Morgan, could only be x times x. I'm going to move your friend, Mr. Morgan.
Oh, sorry.
8 would have to be, for example, 2 times 4. Now, looking at a middle of -2, the signs would have to be, I would need a +2 and a -4 to get the -2. So there I factored it. How would I keep going in order to find the actual solutions?
Make them equal to 0.
Make them equal to 0 and solve it. So I would go like this. All right, x + 2 = 0, x - 4 is equal to 0. By the way, these parentheses are called factors. All right, so x + 2, that's a factor. And x - 4, that's a factor. So the factors very quickly give us the zeros or solutions. X = -2, x = +4. Again, notice that those solutions or zeros are the same thing that you get by looking off the graph and just seeing where it hits the x-axis. Okay?
Which we had graphs for it, yeah.
Sometimes you will. For some problems you will. Okay. Now, for the next 3 problems, we need to do the opposite. I'm giving you the zeros. I'm giving you the solutions. And you need to turn it back into a polynomial. Okay? So here's how you do it. Working backwards. If -2 is the 0, can you tell me the factor that would give you -2?
X + 2.
All right. All right. I want you to hold back for a few, okay? You and Aaron, usually, I know you know everything, okay? So I need to hear from the rest of the class to see if anybody else knows anything for a while. You're so good, you're hitting that shut-off valve for a minute. I got to time you out because you give everyone else a chance. But, of course, as usual, you are correct. If the 0 is -2, I'm gonna have a solution. I'm gonna have a factor of x + 2. Okay, Ainsley. If I have a 0 of 5, guess what the factor is going to be?
If you have a 0
Mm-hmm.
God bless you.
Okay.
It's -1.
Right. When it was -2, I had x + 2 as a factor. So you can bet that when I have +5, +5, I'm going to have x -5 as a factor. Ainsley, remember, the reason for that is look at the relationship between the factors and the zeros. If I have a factor, I wind up setting that equal to 0 and solving. So if I have x plus 2, I'm going to wind up getting negative 2. So to go backwards, it'll be like the opposite. Okay? So to get the polynomial out of this, I'm just going to distribute. I'm going to multiply. All right, Miss Whiteley, are you with me? I'm afraid. I'm scared. Okay. So I'm going to do the distributive property. So x times x, that's x squared. X times negative 5, that's negative 5x. Okay, I need to also distribute the 2. So 2 times x, 2 times negative 5. So that'll be plus 2x minus 10. Then you got those like tisms. So you're going to have x squared minus 3x.
It's minus 3x?
Yes, sir.
Oh, yeah.
Plus minus 10. Wait, I messed up.
Yeah, it's minus 10.
Okay, minus 10. That's the polynomial that you were asked to find. Okay, that's 10. Okay, so far so easy. Sliding, go.
Why isn't it plus 3x minus 10?
Because it's negative 5.
Oh, okay. Yeah, we have a negative 5 and a positive 2. Okay? If I do negative 5 plus 2, which is bigger, the negatives or the positives? Well, negative 5, that's like 1, 2, 3, 4, 5 negatives. Okay? Positive 2, that's like 2 positives.
Are you talking about, are you talking about like how many?
If I put this in your calculator, negative 5 plus 2, see what you get. Okay? You're going to find it that it's negative 3, but the reason is negative 5 is like 5 negative things. Positive 2 is like 2 positive things. The negatives win. The negatives win by 3. All right? Okay, look at number 2. Baby steps. Going to the next step. Last one, I only had 2 zeros. This time I have 3. Okay? But again,
How you do this one?
oh my goodness, man. Let's find out. Demetrius, give me the first factor. All right? I see that negative 4. Give me the factor that I'm going to get from it.
X plus 4.
I'm going to get x plus 4. DJ, give me the next factor, bro. X minus 3. All right, Mr. Morgan, give me the last factor.
X minus 5.
X minus 5. Please stop me if I do something you do not understand. So these are the 3 factors we're going to have, okay? We have to multiply these. We are just going to do it 2 at a time. I like to do the 2 on the right first. Doesn't really matter, but it's what I like to do. Be like me.
You add them together after you get them?
No. Let me show you. So I'm going to do the distributive property like I did before. So x times x, so I got my x squared. X times negative 5, negative 5x. Distribute the negative 3. Negative 3x and positive 15. Okay? Positive. I'm doing negative 3 times negative 5 there. Then I have those like terms. So I'm going to have x squared minus 8x plus 15. So that's all from the yellow part that I highlighted. The x plus 4, I'm just going to bring that straight down. And then I'm going to go on and distribute that as well. Okay? So once again, I'm starting over kind of. I'm going to take that x and distribute over all 3 of these things. Distribute, distribute, distribute. Okay. X times x squared, that is x to the 3rd power. X times negative 8x, that is negative 8x squared. And x times 15, that is plus 15x. So I have that. Oh, I'm losing DJ. Stay with me, buddy. Then I'm going to distribute the 4. And DJ, you should be writing this down. That will help you stay awake if you take notes and write. The minute you start spectating, that's when your mind wanders, and that's one step before you find yourself waking up at the end of class. Multiply everything by 4. So 4 times x squared, So that'll be plus 4x squared. 4 times negative 8x, so that's negative 32x. And 4 times 15, 60. Like terms. Combine like terms. Make sure you put it in descending exponent order, standard form. They got to be in standard form. So in standard form, your final answer is x to the third power. Okay, up, here comes some like terms. Do you see them? I have negative 8x squared, and I have 4x squared. Those go together. Together, that's going to make negative 4x squared. I have more like terms. I have the 15x and the negative 32. What's that? Negative 17x. And then I bring down my plus 60. Okay, so this is my polynomial. Bless you. Alright, that's a 0. Okay, that was the next step in our evolution. Oh my goodness, what's this now? What's he doing? Imaginary. Oh Lord, here we go. Why has he always got to make it difficult? Let me focus on a couple key things that I need you to be aware of. Okay, 2 key things. I boxed them and tried to emphasize them for you in your notes here. Thing number 1, imaginary solutions always occur in plus or minus pairs, called conjugates. So, if you see negative 2i, positive 2i always goes with it. Okay? That's important because this time I gave you them both. All right? But next time, I might not.
Because you always have to
Hold on. Next time, I might not. Okay. Like if you look at number 4, which is coming, just as a future example, here I only put negative 4i. But you're supposed to automatically know that there's another solution that goes with it. What goes with it? 4i. Okay? If you do not add that in, you will not get the right answer at all. Okay? So again, imaginary solutions come in pairs, plus minus. Okay? If I give you the one, you draw in the other by yourself. Okay? Look at number 5. What other solution am I going to just add on to this list? I'm going to add on a negative I. Okay? So just be aware of that. All right. Here's the other thing that I have to emphasize to you. The main thing you need to know about I. I squared equals negative 1. That's just a fact. That's how it's defined. I squared is negative 1. Just memorize that. That's a fact. So anytime I squared turns up in your calculations, replace it with negative 1. All right, so let's go on and begin to do this just like we did the other problem. Let's see. So Tyrone, looking at that first 0, that first root, can you give me my first factor? X minus 1. Juice, give me the next one.
X minus 4.
X minus 4. Okay, Devon, give me the next one.
Yo,
Mr. Chivas.
this is a tough one.
That's all right. It's the other Devon.
Okay, cool.
All right, give me the next one. Okay, this is where we were so far. We did the 1. That was x minus 1. From the 0 of 4, we got x minus 4. Okay, so now we're on this one. Just follow the same pattern. We'll see how we're kind of doing the opposite sign. Okay, so x plus 2i. Keep the I. Okay, go ahead and give me the next one.
X minus 2, is that I?
Yeah, that's I. That's I. X minus 2i. Those are the 4 factors that we would have. All right? Yeah.
Just do it opposite. Always, or no, it's just not the case.
Yeah. That's good enough for now. Okay. I'm going to do 2 at a time. So I'm going to do these 2 together, and I'm going to do these 2 together. Okay? That's how I'm going to do it. Yeah. Never mind? Okay. All right, so first I'm going to distribute this like always. All right, do it with me. It'll help you stay awake if you do the work. If you move that pencil. Okay, so I'm going to get x squared. Rachel, I haven't seen you look up in a while. You know what I'm saying? Are you like getting all this? What? You've been looking up? I'm missing it? Okay. All right, x times x is x squared. X times negative 4, that's negative 4x. Okay. Now I'm going to do this minus 1. Bam, bam. So that's going to give me minus x and positive 4. Okay. So this is what I have so far. Now I'm going to do the yellow part. I'll simplify later. All right, I'm doing the yellow part now. So x times x and x times negative 2i. So x times x, of course, that is x squared. X times negative 2i, I'm just going to put negative 2ix. Just put it all together. All right. Now I'm going to distribute the...
it's 2ix, not
Yeah, just put them in alphabetical order, the letters. So now I'm going to distribute the 2i. 2i times x is positive 2ix. 2i times negative 2i is negative 4i squared. Watch out. I squared. What did I say I squared
1
equals?
So it's just 4.
Not 1, but negative 1. Well, so that's going to change signs, okay?
So you multiply?
It's just 4.
So let me show you. Okay. So now I'm going to go back and combine my like terms, okay? So going back to my first parentheses, I have x squared minus 5x plus 4. Okay, I just combined those like terms in the middle. All right, looking at my second pair of parentheses, I'm going to have x squared. What happens with these two terms in the middle? They cancel out. I have a negative 2ix and a positive 2ix. They're gone. Kabam. Okay. Now watch this and see who can explain to me why I'm about to do what I'm about to do. I haven't even done it yet.
Because it's math.
I'm going to go plus 4 with no I squared. It was a negative 4i squared. Now I put a positive 4 with no I anywhere. What did I do? Jump in. Popcorn. Negative times a negative. Say something. Say something.
I squared is negative 1. Or I is negative 1.
He's
So
retro.
Go ahead.
There's the square root of negative 1. So if you square it, it just becomes negative 1.
What did I say that I squared equals?
Negative 1.
Okay. So this green, this negative 4i squared, is the same thing as negative 4 times negative 1. Okay. Then a negative times a negative is a positive. So that becomes a positive 4. That's where this is coming from. Okay? So that will always happen. So if you see an I squared, it's just going to change the sign of whatever it's next to. Alright, then we have to go on and multiply like we did before. So watch me work, y'all. I'm going to distribute the x squared again, like this. Distribute. Let's see, x squared times x squared. Anybody know what that is? X to the 4th power. That's right. What about x squared times 4? 4x squared. So there I distributed that. Now I need to distribute the negative 5 that's here in the middle.
Negative 5x to the 3rd.
Okay, negative 5x to the 3rd. Very good. Negative 5x to the 3rd. Then negative 5x times 4. All right, that's going to be negative 20x. And finally, I need to distribute the 4. So I'm going to do the 4 times x squared and the 4 times 4. 4 times x squared is 4x squared, and 4 times 4 is 16. Now I just combine my like terms and I'm done. Make sure you keep everything in standard form. All right? So I will have x to the 4th power minus 5x to the 3rd power. I'm going in decreasing exponent order. So 4, 3. Now the 2's. Be careful, I got some like terms here. All right, I have my 4x squared and my other 4x squared. Okay, so together that's going to give me 8x squared. Okay, then comes the minus 20x, and then the plus 16. Okay, that was a long polynomial. Okay, bam. So that's what you have. All right? So that was number 3. Flip over to the back of the paper. Okay. Now, the main thing, I'm going to sort of skip over number 4 and 5 because they're the same. All right, the main thing, other than just giving you practice, keep that head up, Osman. I already mentioned how if you have a negative 4i, you must go ahead and throw in the positive 4i that goes with it. I already mentioned that if you have an I, you need to go ahead and throw in negative I. Okay? I will do the factors real quick. So the factors would have been x minus 3 from the 3, x plus 4i from the negative 4i, and then x minus 4i from the positive 4i. And you would multiply those together just like I already showed you. Okay? And then on number 5, the factors would be x minus 1, x minus 6, x minus I, and x plus I. Okay? And you would multiply those out 2 at a time. Okay? But for now, we better skip on ahead to the graphs. Okay, now here's what you need to know about these graphs. All right, look at this chart. The behavior of the graph when it touches these x-intercepts depends on something called multiplicity. All that means, that's a fancy word for how many times is the factor repeated. Is it just a single, like normal? Like if I just have an x minus 2, that's just a single. If it's just a single factor, of course we would set that equal to 0, and that would give us x equals positive 2, right? That's why I show this graph over here hitting the line at positive 2. If it's just a single like this, it just goes straight through, passes straight on through the graph at that point. That's what usually happens. That's very common. Now, slightly more unusual, but it does happen. If you have a double, all right, it's an x minus 2, but it's squared. There's 2 of them. What happens is you get a bounce right there. So, Rebecca, when the graph comes down and touches that x-intercept, it does not pass through the graph right there. It bounces off the x-axis right there, and it does a bounce. Okay, it goes back the way it came from. Now, if it's a triple, and you have to basically memorize this. If it's a triple, all right, then you get what's called an inflection. So what it does, it passes through the graph, but it sort of curves and flattens out a little bit, and then curves the other way and keeps on going. That's an inflection. Okay? You have to memorize that. So now looking at problem number 6 as an example. So here I'm giving you the graph, and you're supposed to take this and write me a function. You're allowed to leave it in factored form. Start with the easy part, the zeros. Hopefully you guys can see that I've got 2 x-intercepts. I've got 2 zeros. I've got one here, and I've got one here. Okay? So this first one, do you see how it passes straight through? Okay, so just to be super clear, it goes through the graph at negative 2. Because it passes straight through, is that a single, a double, or triple?
Double.
Look at that chart. Look where it says it goes straight through. Straight through. Find it on the chart. What does it say? 1. Okay? When it goes straight through, okay? Straight through, that's a multiplicity 1. That's a single. Okay? And that's when it goes straight through the graph like that. So for this first one, at negative 2, It goes straight through at -2. So what's the factor that I'm going to get out of that?
X plus 2.
That means I'm going to have a factor of x plus 2. And I know it's going to be a single, just plain x plus 2, not squared, not cubed. Okay? Now look at the next one. At the next one, does it go straight through, or is it a bounce, or is it an inflection? At 1 over here, it's a bounce. So I'm going to just write this down like notes, okay? I see a bounce at +1. Can you translate that into a factor for me? So I'm going to have x minus 1, but it's because it's a bounce, it's a double. So I have x minus 1 squared. All right? If it bounces at the 0, it's a double. Okay? And that's all I have. So I can go ahead and write my function now. So I will have f of x equals. Okay? And I see x plus 2. And then I see x minus 1 squared. That's my function. The only other thing I have to pay attention to, one more little thing. Is this the positive version or the negative version of this graph? I know it's been a few days since we talked about this. All right? This is, do you remember the n that we learned about? Can you see the n? All right? Is this a right side up n or an upside down n?
Right side up.
That's a right side up n. That means this is positive. This is a positive graph. So I will just leave it like it is. If I saw an upside down n, I would have to put a negative sign here in the front. Okay? All right, I'm going to have to stop it there. I really encourage you to watch the video tonight. Watch tonight's homework video, please.
So, what are we doing with that?